This GCSE revision video covers chapter 1 from the textbook. You can see the topics that are covered, so we will go through each one of those. So let's start with the first one, which is recognizing multiples, factors and primes. So we'll start with multiples. So for example, e.g. if I was to do the multiples of 6, they would be 6, 12, 18, 24, 30, 36 and so on. So they're the numbers that you would see in the times table. If I were to look at the factors of a number, so with factors, rather than being bigger than a number, they're smaller. So e.g. if I wanted the factors of let's say 30, the easiest way to find the factors of a number are to write the multiplications that make the number. So for example, 1 times 30, 2 times 15, 3 times 10, 5 times 6. So I'll stop there, I've written all the multiplications out. If I was to write another multiplication, can you see how I'm going in order here? 1, 2, 3, the numbers that go into 30. If I was to carry on, the next multiplication would be 6 times 5, so I'll end up repeating myself. So now I can just write the numbers I've written down. So 1, 2, 3, 5, 6, 10, 15 and 30. So here, these are all the multiples of 30, and I use the multiplications to help me. And primes, well, these are just like prime numbers. So remember, 1 isn't a prime number, so we start with 2, 3, 5, 7, not 9, 11, 13, 17, 19, 23, 29, I think it's next one. Yeah. Make sure that you know the multiples, or sorry, the primes up to 30, and you should be able to recognize those numbers. And all of those primes that I've written down, we can only ever write them as 1 times something. If you can't write any other multiplication, then it's a prime number. So make sure you can recognize those. Okay, so that's the first topic done. So the next thing we're going to look at after that is multiplying and dividing negative numbers. And in fact, we'll look at adding and subtracting negative numbers as well. That will be useful to do. So let's start with multiplying and dividing negative numbers. And the rules are that if you multiply two numbers which have the same sign, so they're both positive or they're both negative, you'll end up with an answer which is positive. If you multiply two numbers which have different signs, so one is positive and one is negative, so multiply or divide, different signs, you'll always end up with an answer which is negative. So I'll put some examples here. So for example, if I had 5 times negative 6, or 5 times 6 is 30, because the signs of these two numbers are different, it will be negative 30. If I had 16, let's have negative 16 divided by negative 2. Now you might see a question like this written like this, with the negative 16 in brackets and a negative 2 in brackets. It's the same thing. Now 16 divided by 2 is 8. Since those numbers have the same sign, the answer is going to be positive. Now we don't need to put the positive sign in, because we know that no sign in front of a number, means it is positive. Yeah, so you can see in those calculations, when the sign was the same, it's positive. When the signs are different, it's negative. So here's another one. Let's say I had negative 12 times by -3. So 12 times 3 is 36. They've got the same sign, so it's positive. And one more. Let's have 15 divided by -5. Just put that in brackets. So 15 divided by 5 is 3. And since one is positive, one is negative, they've got different signs, it's going to be negative. So that's the rules for multiplying and dividing. What about adding and subtracting positive and negative numbers? Well, we do have similar rules. If in a calculation you see a plus sign and a plus sign next to each other, or you see a minus sign and a minus sign next to each other, you swap it for a plus sign and do the calculation. If you see a plus and a minus next to each other, or a minus and a plus next to each other, you swap it out for a minus and do the calculation. So here's some examples. So let's say I had -5 minus -7. So here I see the two negatives next to each other here. So I swap them out for a plus sign. That's the rule. So it becomes -5 plus 7, which is 2. Okay, here's another one. Let's say we've got 16 plus -20. So here I see my plus sign and negative sign next to each other there. So I'm going to swap that out for a minus sign. So I would do 16 minus 20, which would be -4. So just make sure with these calculations as well that you're clear on doing questions where you may be using a number line like this one, so you know it's not going to be 4 the answer, it's going to be -4. So just be clear about actually getting that calculation right. So now we can multiply, divide, add and subtract with negative numbers, positive and negative numbers. Right, the next topic is being able to round to a given number of significant figures. Now we have two types of rounding. We have rounding which is decimal places, DP, let's see that, and we have rounding which is significant figures. And the way we do those types of rounding, so SF like that, is slightly different. So let's just go through both. Let's start with the decimal places rounding. So let's say I had a number like 3.15796, and I want you to round that to one decimal place, or 1 DP. What I would do is after the first decimal place, I will draw a line like this. Yeah, so after the first decimal place. And then from there, what I would do is I would have a look at the numbers either side of that line. Now, the number in front of the line is either going to stay the same or go up. Numbers either stay the same or go up. Because this is a 5, if it was a 5, a 6, a 7, 8, or a 9, it means that this goes up and this would become 3.2. So to one decimal place, it becomes the number 3.2. Let's say instead I was asked to round that to 2 decimal places. Well, my line would now go after the second decimal place. I do something similar to what I did before, and I would look at the digits either side of that. So this 5 is either going to stay the same or go up. In this case, because that's a 7, this goes up to 6, so that's going to be 3.16, and so on. Okay, so that's rounding to decimal places. Now we can use a very similar method to round to significant figures. Okay, so let's say we have this number 427.81, and I was asked to round that to one significant figure. Now when we did rounding to decimal places, we actually started counting from the decimal point. So we said 1 decimal place, 2 decimal places, so on. That told us where we drew the line. Significant figures, you don't start at the decimal places. You start counting from the start of the number. So we don't start counting from 1, 2 like this. We start counting from here. So after the 4, we draw a line here. So again, we look at the digits either side of that line. And because there's a 2 after the line, that means in this case that the 4 doesn't change. It doesn't go up to 5, it stays as 4. So I'll write it down as 4. But we need to write any digits after that line as zeros. If we didn't, if I just wrote 4 down, left it as it is, I've changed the number completely. See these numbers in front of the decimal point? I need to write these as zeros. So it becomes 400. So don't forget any digits that are in front of the decimal point, which are after the line, we write as zeros. We didn't worry to do that here. I could have written all these digits after the line as zeros, but it wouldn't have changed the size of the number. Any zeros at the end here don't change the size of the number, but the zeros here in front of the decimal point do change the size of the number. So that's going to be 400. So let's try 2 significant figures. So that line is going to move and go here. So again, if we look at the digits either side of the line, so this time that 2 is going to go up to 3. So I'll have 4, 3 in front of the line. But remember, this digit here must be written as 0 because it's in front of the decimal point. So we end up with 430 or 430. And we'll do one more. Let's jump to 4 significant figures. So now the line is going to move, and the line will be 1, 2, 3, 4. It will be here. Again, we look at the digits either side of the line, the digits which are in front of the line and after the line. This 8 isn't going to change because that's just 1 there. So I end up with 427.8. 427.8. Okay, there's only one difference, and that's if I'm rounding a number like a decimal with significant figures. So let's say I had this number 0.00057338, and let's say I was rounding that to 1 significant figure. Now with the previous example, what I did was, remember I started counting the significant figures from here, 1, 2, 3, 4 and so on. Now with a number like this which has zeros in front, what we call leading zeros, you don't count the zeros. You wait until you get to a non-zero digit, which is the 5, then you start counting 1, 2, 3, 4. Don't start counting from here. So you almost ignore these in a way when you start counting the significant figures. So 1 significant figure, the line is going to be after the 5 there, not right near the beginning after the 0. And then I carry on the same way. There's a 7 there, so that means that 5 will go up to 6. I still put the zeros which are in front. I don't want to change the size of the number. So 0, 0, 0, 6. Let's try 2 significant figures with the same number. So this time, if we count the significant figures, our line is going to be here. The 7 is not going to change because there's a 3 after the line, so that'll be 0.00057, and we'll do one more. We'll do 3 significant figures. So that line now is going to be here. So that 3 at the end is going to change to a 4 because there's an 8 after the line. So I'll end up with 0.000574. So that's rounding to significant figures. Okay, the next one where it says that you can estimate the values of a calculation involving negative numbers. Well, the way that we do that, to estimate a calculation, so that means find the approximate answer, not the exact answer. Okay, to estimate a calculation, one thing you do not work out the exact answer. Don't do that. Yeah, it's wasting time and you're likely not to get any marks. What you do instead is round the numbers in the calculation to one significant figure, and we've just done rounding to one significant figure. So here's an example. Let's say I had 7,941 and I'm timesing that by let's say 27. Now we use these little lines here to say that the answer I'm working at here is not going to be exact, it's an estimate. So one significant figure, let's put these lines in. So there'll be a line there and a line there to help me round. So the 9 at the in the 7,941 makes the 7 go up to an 8, so I have 8,000. And the 27, the 7 will make the 2 up go to 3, so I end up with 30. And this I can do, 8 times 3 is 24, followed by 1, 2, 3, 4 zeros. Okay, so that's how we would do it. Round the numbers to one significant figure. Next one, where it says we want to be able to write a number as a product of primes. Okay, that involves drawing factor trees for a number. So let's do some factor trees. Let's do a factor tree for 36. So just like when we're writing factors, we want pairs of numbers that multiply to make that number. So let's say 18 and 2. Now what you must do with a factor tree is circle any prime numbers, because that's going to be the end of the branch. So I circled a 2. Yeah, that's the end of that branch. 18, I can write as 6 times 3. 3 is a prime number, so I circle that branch and end. And 6, well, I can only write that as 2 times 3. They both get circled. Now there are different ways of doing this factor tree. I might have started off, instead of doing 18 times 2, I might have done 6 times 6, and I'll have a different factor tree, but you'll end up with the same numbers. Now when you've done a factor tree for a number, there's a few things that we have. So first of all, I could say that the prime factors of 36, well, they're all the different prime numbers that I have circled, and the different prime numbers I have circled are 2 and 3. So the prime factors of 36 are 2 and 3. They're the different numbers that I have circled. There's also another thing called the product of prime factors. So I can say 36 as a, or written as a product of prime factors is, well, it's basically all the numbers I have written multiplied. So there's a 2, a 2, 2 and a 3. So I would write it as 2 times 2 times 3 times 3. So this time I use order numbers, or if I use powers, I can write it as 2 squared times 3 squared. That gives me the value 36. So from the factor tree, we get the prime factors of a number, and in this case, the prime factors are 2 and 3, because they are the different numbers that are written down. I've got 2's and 3's. And we can also find a prime, the number written as a product of prime factors, and that's all of the numbers multiplied together. Now this will lead us nicely onto the next bit, because the next bit says I can work out the HCF and LCM of a pair of numbers, and we can do that using factor trees. Now I'm going to do one more factor tree. I'm going to do a factor tree for 45. So here's my factor tree for 45. I'm going to do 5 and 9. 9's not a prime number because that can become 3 times 3. So here's my factor tree for 45. And let's say I wanted to find the HCF, which is the highest common factor, and the LCM, which is the lowest common multiple. Let's say I wanted to find those HCF of LCM of these two numbers, 36 and 45. So the first thing I would do is to draw a factor tree for both of those numbers, which I have already. Then the next thing that I would do is to put all of that information from the factor trees into a Venn diagram. So let me show you how that works. So a Venn diagram, we're going to have a box like this. We are going to draw two overlapping circles like this. In one of those circles, I'm going to put in the prime factors of 36. In the other circle, I'm going to put the prime factors of 45. So what that means is, in the middle, where I have this overlap here, I'm going to be writing down the prime factors of 36 and 45. In other words, numbers which I see in both factor trees. So let's just highlight these numbers here like this, and let's look at which numbers I have in both factor trees. So there's a 3 here, and there's a 3 here. Yeah, so I'm going to put a 3 in the middle. That's in both. Any other numbers in both? Well, there's a 3 here and a 3 here. That's in both, so that goes in the middle. Then any remaining numbers go in the other bits of the circle. So in the factor tree for 36, there are 2 2's. So I'll put a 2 and a 2. And in the 45, there's a 5. There's a 5 there. Now, if I want to find the highest common factor, I multiply the numbers in the overlap. So I would multiply together these numbers here. See those? If I multiply the numbers in the overlap, that will give you the HCF. So let's write down here, HCF equals, well, you times all the numbers you see in this bit of the diagram, yeah, this overlap part. So in this example, the HCF of 36 and 45 is going to be 3 times 3, which is 9. Not 3 times 9, 3 times 3 is 9. Like that, so that's the HCF. If I want to find the LCM, then we multiply all of the numbers you see in the Venn diagram. So everything you see inside the Venn diagram like this get multiplied together. So in this example, the LCM and I could probably highlight those. So that's basically going to be every number that I see. The whole thing here is going to get multiplied. So that's going to be 2 times 2 times 3 times 3 times 5. Just about got enough space. So 2 times 2 is 4. Times by 3 is 12. 12 times 3 is 36. And 36 times 5, I think is, yep, 180. So 180 is the LCM of these two numbers. In the next bit, where it talks about using a calculator efficiently, there's not a lot I can say about this. Just a couple of things. The first thing is you often get like a calculation, complicated calculation. They want you to work out on your calculator. The first thing you need to make sure is that the calculation basically just looks exactly the same as it does in the question. So it looks exactly the same on your calculator as it does in the question. Make sure that they look exactly the same. That's the first thing. The second thing is if you want to type in a mixed number on a calculator. Now to type in a mixed number, most calculators you need to press shift or second function first, then press the fraction button, and then what should come up on your screen are 3 boxes like this. Yeah, so make sure that's how you type in your mixed numbers. And if you need to give an answer to an appropriate degree of accuracy, then you may choose 1 decimal place or 3 significant figures. It's up to you, but whatever you round it to, make sure you write in the question, or you write in your answer, what you've chosen to round it to. Yeah, don't just write it down. Write down next to it that you've rounded it to 1 decimal place or 2 decimal places or 1 significant figure, but choose a sensible way to round it. Now the next two here are to do with square roots, so we'll do these together. So we need to be able to work out maybe the square roots of some decimals. This is without a calculator. So for example, if we know that the square root of 9 is 3, we could actually work out the square root of 0.09, which would be 0.3. If I know the square root of 16, which is 4, then that allows me to work out the square root of 0.16, which would be 0.4. And we'll do one more. Let's say I knew the square root of 81 is 9, then the square root of 0.81 is going to be 0.9. Yeah, so they're useful to know and to work out. So if you know the square root of a whole number, you can use it to work out the square roots of some decimals. And if I want to estimate square roots, so if I were to draw, let's say for example, I know that the square root of 25 is 5. The square root of 36 is 6. Let's say I needed to estimate, and it would be estimate, the square root of, let's say, 27. Now looking at my list of square roots that I have here, well, it's going to be bigger than 5, but not as big as 6. And 625 is closer, or 27 is closer to 25 than it is 36. So maybe I expect my estimate to be like 5.1, 5.2, 5.3, not 5.9, because then this number would have been closer to 36. So we can use the fact that it's between these two, look at how close this number is between each of these numbers. It might be exactly in the middle, but it's not. It's closer to 25. So I expect my estimate to be closer to 5. So I would estimate, I don't know, 5.2 maybe. Yeah, it is only an estimate. So in an exam, if you did 5.1, 5.3, you'd probably get the mark as well. Now the last couple of sections, we've done this already here, working out the HCF of two numbers from their prime factors. That's when we did the factor trees, and then we did the Venn diagrams. So that was back here. Yeah, so we did it in this section, so we don't need to do it again. So that bit's done. Then the last section, I can use rounded numbers to give inaccuracies to work out complex problems. Well, that's just a combination of maybe using your calculator with worded problems. If it says complex problems, they tend to be worded ones. And they tend to be things where you're comparing two different options. And you need to decide what calculations you're going to do, often on a calculator paper. And then once you've decided on those calculations, you may decide how you're going to estimate your answer. So there may be some estimating to do as well. But estimating would probably occur on a non-calculator paper. And I've shown you how to do estimating. And yeah, that's it. That covers all the content from chapter 1 of the textbook.